We have to find minimum or maximum value of quadratic function. When we have to find the minimum or maximum value of quadratic function, we need to find the vertex of the graph of the function. Why? Let me remind you, the graph of quadratic function is parabola. Parabola can be open up or open down. Let me draw x, y coordinates. For example, here will be parabola opens up and parabola opens down. This is our vertex. And for example, where a is greater than 0, we have parabola opens up. We see that when we are going up on the right side, on the left side of our parabola, the values, because value of our function going up. You see, we are going up. This point gives me the minimum y coordinate. We cannot have smaller value than this value. So when we have parabola opens up, when we calculate the vertex, we have minimum y coordinate. This is the smallest value. And when we have parabola opens down, a, it means a is less than 0, the vertex give me maximum y coordinate. Why? Because on every point of our graph, when we go to the left or to the right side, the values are go down. We are going down. So to negative infinity. So the values are smaller. This point, for this point, we have maximum y coordinate. We don't have greater value than this for vertex. And so now when we have to find minimum or maximum and we have given quadratic function, first we always check the coefficient before x squared. When the coefficient is less than 0, because we have in this example that a is equal -1, so this is less than 0, it means that we have here maximum value of quadratic function for the vertex. So, because our function has negative, like I said, a, we have maximum of the function for our vertex. So we need to find the vertex. Let me remind you formula. When we have quadratic function general form, y is equal a x squared plus bx plus c. The coordinates of our vertex are negative b over 2a, and the second coordinate is f of negative b over 2a. This is a x coordinate, this is y coordinate. We need to find y, but to find y we need to have x. So first we have to know a, b. So a is -1, b is -3, and c is 10. So first we need to find x, first coordinate of vertex, and is equal -b over 2a. So this is equal, negative sign we copy, b is -3 over 2 times -1. So this is equal, negative and negative give me positive, and we have one more negative, so it will be -3 over 2. We have x, so now we will find the second coordinate, y. is equal f of negative b over 2a. So this is equal, we found that negative b over 2a is negative 3 over 2. So we have f of negative 3 over 2. And now we have to go to our function and we need to substitute x's by negative 3 over 2. So this is equal, we have negative sign and in parentheses negative 3 over 2 to second power minus, and in parentheses, of course I forgot, 3 times negative 3 over 2 plus 10. So this is equal, we have negative sign and negative 3 over 2 to second power, so it will be 9 over 4. Negative times negative give me positive. 3 times 3 is 9 over 2 plus 10. We have fractions. To add these two fractions, we need to have the same denominator. We have 2 and 4, so the common denominator will be 4. 2 I need to multiply times 2 to get 4, so the same I have to do with numerator. So we have negative 9 over 4 plus will be 18 over 4 plus 10, of course. So this is equal. And we have the same denominators. So we copy the denominator and we have negative 9 plus 18 is 9 plus 10. So this is equal 9 over 4, this is improper fraction, so I can change to mixed numbers, so it will be 2 and 1 over 4 plus 10, so this is equal 12 and 1 over 4. So now we have vertex of our quadratic function. The vertex is negative 3 over 2 and the second coordinate is 12 and 1 over 4. And now the coefficient before x squared, like I said, is negative. So this is the graph of our function approximately. So the parabola is up and down. So the vertex give us maximum of the function, so maximum value of the function. So the maximum value of the function is 12 and 1 over 4. And you have to memorize that this is the y-coordinate of the vertex. The y-coordinate of vertex give us maximum value of quadratic function. When we have parabola opens up, then we have, when we calculate the vertex, we have minimum value of the function, because when we go up on our parabolas on the right, on the left side, the values go up. They go to infinity. So we cannot tell the maximum value because we still can find the bigger value. Only the minimum value we can tell. When we have parabola opens down, we can tell the maximum value because the parabola goes down, so these values are smaller. Every time where we go on the left side or on the right side or on our parabola, we are going down, so values are smaller. So this is maximum. When we have parabola opens down, we can tell the maximum value. This is my solution.